Okay, I thought I'd just go through how to solve these questions in measurement and geometry for all these geometry concepts. So the circle property stuff. So let's just go through each question and fast forward or stop it when you need to. Okay, question A. Triangles add to 180, so we just have to subtract everything from 180 and we will get 36 degrees. So all I did was 180 minus 118 minus 26 equals 36. This one right here is an isosceles triangle, so I know both of these angles are going to be the same. So if I just do 180 minus 87.4, I'll just write that down. I will get 92.6. And then if I just divide that by 2, I will know how much each of those angles are, the x's. So now I know this angle is going to be 46.3 degrees. This one's an equilateral triangle, so I know each angle is 60 degrees. So since this one is on a straight line, I know supplementary angles add to 180. So if I just do 180 minus 60, I will get 120. There's also a thing that says this angle is equal to the sum of these two angles. Another theorem. Okay, question D is that question where if something goes through the diameter like that, and then you make a triangle out of it by connecting to the circumference here, this angle will always be 90. So x is 90 degrees there. This one's our twice angle thing. So these two angles are subtended by this arc, by the same arc. So see, we can make this angle through that arc, and we can make this one. So the center angle is always twice. So it would be 120, 60 times 2. Okay, this is our cyclic quadrilateral. So we know that opposite angles add to 180. So if I just do 180 minus 80, I know that angle x is going to equal 100 degrees. Okay, these guys. This one, I'm thinking you probably need to prove that this is likely an isosceles triangle. So if we do 180 minus 36 minus 72, we get 72. So now we know this must be isosceles and x must be 3 centimeters. Okay, this guy is one of those ones where, like, say you picked 2 points like this. So this is the arc that they have the same arc. So we're getting one angle by doing this, and the other angle by doing this. So we said before that those angles are equal, so x must just be 40 degrees. This one, we know that this angle is going to be 90 because that's our going through the diameter thing. So if we just do 180 minus 90 minus 46.8, we'll figure out what x equals. Okay, so 90 minus 46.8, 43.2. Okay, this one is another one of those center angle things. Guess I don't need to trace it. So this angle is going to be twice as big as x. So if you take 107.6 and divide it by 2, that will be what x equals, which is 53.8 degrees. Okay, this one is where we take 2 points and like one angle is 57 and then the other angle is a 57 also because they're the same angle. This one is tricky. It kind of looks like the one we just did, but it's not because it's going through the center of the circle. So I know I've got this angle right here, x, and then this one, which is subtended by the same arc, but this goes through the center. So I know that x must be twice 31 degrees. So x must be 62 degrees. That's a tough one. Okay, and these last three I didn't talk about because I don't actually think you need to know them. But just in case you do, this is a chord. This is called a chord. It just goes from one side of the circle to another side. And it's always true that if you have a line that goes from the center and it's perpendicular, like the chord here is perpendicular to the line from the center of the circle, which it is, then these two segments will be equal. It actually bisects the chord. It splits it into two equal parts. So this will be 5 centimeters and so will the other side. So if you ever have a perpendicular coming from the center of a circle to a chord, it will always split it in half. And these ones are fun, interesting. This is actually called a tangent line, which I guarantee you don't need in grade 9, but it doesn't hurt to know. So it's a tangent line, so it just touches the circle at one point. And then this line right here is the radius of the circle. So it turns out the angle between a tangent line and the radius is always 90 degrees. So x would be 90 there. And then this one also, this is that theorem where if you have a chord, if you have a perpendicular from the center, it always cuts the chord in half. And since it did cut the chord in half, then we know that x must be 90 degrees. But yeah, I don't know if you really need those 3 at the bottom there. But that's how you do them all.